So I want you to write this down, so you can see, right? Now, sticking out a bit with maybe some arrows and some lines, I want you to make note that this will be all the background information that we give you about the filling board and any information you have about the sites as well, the individual sites we went to. In particular, the background about the filling board we gave you this morning. That's the kind of stuff that they're talking about there. If you were to do any research yourself, read up about it, use the UC Ordnance Survey coordinates that you had earlier on to look up the site with Google Earth and learn a little bit more about it. That would be useful as well. Methods of data collection. Now, I'm told that you guys are pretty good on your how to describe data collection, how to describe your methods. But just as a sort of guide, there is a table in your book called Control Assessment Methodology Table Scaffold. Scaffold means like a kind of a background that you're dealing with helping with this. Okay? Have a look at that. It's on about 4 pages, 4 or 5 pages in. Okay, so it says variable, which is like what did you measure. So for example, one of the variables we measured was depth. Okay? And then equipment used, we talked, just mention the names of things. If anyone wants me to explain the names of any of the equipment or how to spell it, I'm happy to do so. The method, this is where you would write a very detailed description of exactly how you did it. Okay? And for example, you will justify all the different bits that you did. So how can we took multiple, when we were doing our depth, how can we took multiple depths? I was pointing to that.
So we can make sure that what we took is accurate.
And anyone else have another answer?
So it's different depths in the river.
Yeah, but how come we couldn't just use one and how come that wasn't represented in the case?
Oh, because it changes.
Yeah, it does change. So we decided to go with an average. What's useful about an average? Okay, it's representative because we had a range of different values, didn't we? And we needed to go with a figure that would represent all of those, but without being massively influenced by any particular one. Okay? So can you, if you imagine that we had only taken one reading, what problems might have happened? Yeah, okay, we could have put our our meter stick somewhere that was uncharacteristically shallow or perhaps uncharacteristically deep. Okay, so the reason why you do multiple samples like that is because the effect of each reading is lessened if you have a large number of samples. Okay, but that's the kind of detail you need in your method. You have to justify what you did and why you did it.
What's, that spin thing?
Yes, so I'll write that up. So the thing that we used for measuring velocity was called the hydrograph. Okay, and the black propeller device behind it is called the impeller. Okay. Is there any other terminology you would like me to explain or stuff? Okay. Now, when you do your methods, girls, it needs to be like a set of instructions or like a recipe. It needs to be so detailed that somebody else could imitate exactly what you've done. So if somebody was to come along next week and read your methods, they would need to be able to replicate exactly what you did today, even if they hadn't seen you do it the first time. That's how good they need to be. Okay, so nothing can be left to chance. You need to explain every little bit of it. It's as if you're talking to an idiot. Okay, explain every little detail.
What's this on data evaluation and implication?
Yeah, so data presentation and analysis is the next one. I will focus a little bit on this in the time we have, and that's because we can briefly get into GIS and stuff like that. Once you have your data, you're going to have tables and tables and tables of data, and you will need to present that in your report. But is that easy to look at or easy to interpret?
No.
Okay, not many people enjoy looking at just massive tables of data. Okay, it's not really the friendliest way for us to look at it or interpret it. So we need to make visuals out of it. What ways do people tend to do visuals for information like that? Okay, things like graphs. What else can we use given that this is geography?
Maps.
Yeah, we can use maps. Can we integrate them somehow? Can we have maps that include other information?
Yeah.
Yeah, like what? Okay, well, how can we use them together? Okay, it's what's called, yeah?
Oh, could you have a map and then have like things like coming off it into like different information?
Okay. So you could put other information onto the map in the relevant places, So perhaps for each of the sites we went to, you could include little pieces of graphs, maybe bar charts or pie charts, something like that. Okay, that would be like a located bar charts or located graphs. Yes?
Can you spell, what was it? Sinuosity, please.
I'll try. I'll double check that against.
I think that's right.
It looks like I'll double check against the PowerPoint when I'm done talking about this. Okay, remind me of that. It's not a word I have, just by chance, it's not a word I have to spell for.
No, that's right.
Okay, and then you have your evaluation conclusions. Now for this, I want you to make note of this. Basically, you'll be trying to explain your findings in your data. And to do that, you will need to use the information that we gave you about the individual sites. Okay, so you're looking at your final information in your graphs and you're thinking, okay, this is what I think I found. Now what can explain this? And you need to think back to what the site was like, what you yourself thought about how influenced it was by people, how natural you thought it was or wasn't, and use that information to help you explain what you found. Okay, so all the information we gave you about the sites is the kind of thing that you want to use in there. Okay? I'm not going to get into this right now. We've spoken about this. Other things to include in your setting the scene. So your investigation question or hypothesis. Expected outcomes, what you expect to get out of it. How it links to the specification, relevant information of the location. This is the main one that we provide, if you like. This is the main bit that you will be covering with what we did today. Okay? But it's worth noting these as well. Especially you will need to include a question or a hypothesis. So has anyone got a nice definition for a hypothesis?
Is it like an idea of like something that you think is, and then that you have to test to like prove right or wrong?
Yeah. So it's like a prediction that we make.
Yeah.
And the prediction will either be right or wrong. Does it matter if it's right or wrong? Okay.
No.
Our prediction is wrong. Does that mean we're wrong?
No.
No. It just means that we've learned something. Okay. So science is our geography as well. It's about it's not just about knowing what you think you know before you actually test it. Because you have the answer already, so there's no point in doing the experiment. Okay.
Wait.
Sorry.
Thanks.
Is everyone alright with that?
Oh, no, please have one.
So remember, a question for this, a question would be, an example of a question would be, how natural is the stretch of river that you were studying? But a hypothesis needs to be more specific than that. Okay, it needs to be something that you can either prove wrong or right. So an example hypothesis for that would be, as you get further, as you travel further away from the source, the river will be more influenced by man, or will be less natural because of influence by man, something like that. Because you can either prove or disprove that. Okay? So that would be a hypothesis, and the hypothesis is more specific than a question. Okay, you're just sharpening your focus a little bit to allow you to actually study it in a way that you can prove or disprove something. Okay, can I move on? Oh,
Sorry.
okay. Just have a little bit of time. I'm trying to get as many ideas out there. Just suggestions for the direction that you might take your thing after this, okay? Locate the study area in detail, okay? So find out as much what you can as the area. Like I said, we gave you some background information about the river Kenninghorn. You could also go to Google Earth, and there are other applications out there as well that you can, some you can get on the internet for free, some of them you can download for free. That will give you more geographical information. As much stuff as you can include in your project is always a good thing, okay? Just shows that you've learned a little bit about the area, and you might find extra information about it that might help you out to answer your questions at the end, and will help you with your analysis and with your, basically the end if you were to look up this area and find out more about maybe green sandstone, something like that, if you were to find out more about Leaf Hill and about what the difference is in heights and what that would mean for how the channel changes, and maybe you could research other artificial waterways, find out what you would expect, what kind of measurements you would expect on a waterway that's artificial or a waterway that has been affected by people, as opposed to one which is completely natural. That will help you to explain your findings as well. Okay, so the local knowledge is really, really important. Okay, so the local area, get as much information about that as you can, and we recommend using maps and things like Google Earth as well. Okay, so for example, this person was doing a study perhaps on the local area here. They're talking about Box Hill, which is just over there, and they found out that it's owned and managed, who owns it, who manages it, what are the facilities, and what would be the exact coordinates for the area, and they're using the map to give them other information about the facilities around it and access to it and stuff like that. Now this person, like I said, this isn't a rivers project, this is probably a tourism project in Box Hill, but a lot of the same ideas are similar. Okay, you could get information like this about the areas we've been to and use all this extra information to add to the stuff that you've found. Okay, does that make sense? Do you see how you could use that to augment your project?
Yeah.
Okay, just even by looking at a map, including maps of the area in your project, you're already bombarded with information like access, who is, what kind of facilities are nearby, is there any sources of pollution to the river, is it heavily used, and the bridges that we crossed, are they heavily used? Will this affect what the river, what the sites look like to us? Will this mean that there's a lot of foot traffic on it that will result in erosion on the sides? Anything like that you can add is really good. Okay? Use of geographical information systems. So this is somebody using Google Earth. This is using the whole field center from the air, and they've overlaid polygons onto this. Now I'll show you one or two little things you can do in Google Earth that are very simple. You can do really, really sophisticated things with it, if you're interested. Somebody here has overlaid another map onto the area. So this is the area as it is now, and this is a map from perhaps some time ago. So various programs you can get will allow you to do that. And what I might do, while I'm talking about it, is open up Google Earth and see what kind of things you can add onto it. Okay. Does everybody use it at home for any reasons? Has everyone at least messed with it and played around and looked for their house on it? Yeah. Has anybody really never seen it at all?
I've seen it.
Okay, so it's a really, really clever program. It's so clever that it's almost, I won't say idiot proof because I'll probably get something wrong now in a minute, but you can be quite broad with it and it will give you results. So